Data sets, values of construction. Improving data collection process. Data collection must be an accepted idea throughout an organization. This starts from the lowest paid employee to the top executive and CEO. An organization must implement routines and processes for collecting, analyzing, and monitoring data, including and lagging indicators to inform continuous improvement, provide feedback, and make decisions. Improving data quality part 1. Issues with data quality can hinder a business decision-making process. This goes especially through the data collection of a construction site. Engineering data are also typically shared among various technical and business systems. The unique characteristics that is most relevant for the problem definition is that the correct answer or the values to be inserted into an engineering asset data record is not always known at the time of insertion. Therefore, in keeping with concurrent engineering, engineers have to proceed with partial data. Clearly, this can lead to poor data quality. Improving data quality part 2. The overall objective of data quality is making good decisions. With corrupt data, a bad decision would be the end result. In order to make better decisions, an organization must find ways to improve quality of data through each sector of business. First, the company should understand the purpose and context of data. Data is an investment opportunity to analyze unused and uninvolved data within an organization. This type of data can determine whether the data is worth collecting. Second, a company should create a data dictionary that will identify good data elements. The dictionary will not only specify rules when breaking down words and data through type. It is a coding system to remove useless data and retain any relevant data needed. Third, using static data can review the overall collection of data, such as record keeping. Is data being deleted too often? Should it be retained any further? These questions offer an overall quality assurance effect through trend analysis. Improving data quality part 3. Fourth, the data should be cleaned by reviewing analytic issues that involve lowercase and uppercase letters, zip codes, social security numbers, telephone numbers, dates, and abbreviations. Fifth, the data should be objectified. By limiting the redundant value of words and numbers can strictly diversify repeated data. Sixth, know where the data originated itself. Obtaining data from the direct source is the best way to receive, dissect, and implement data into a system. Data may become corrupted through second or third party channels. Seventh, always store data through an algorithm and formula and never the end result. Eighth, when data becomes missing, be vigilant in pursuing the data. Also be careful not to mix inputted data with real data analysis. The results may vary. Lastly, perform a regulatory review of data analysis in order to uncover anomalies. Improving visualization part 1. Interactive visualizers foster self-sufficient users that will find the data they needed. Organizations with interactive data visualizations are 48% more likely than static visualizers to have a strategy for making BI user more self-sufficient. In 2014, interactive visualizations users need to explore data without continuously relying on IT support. Static visualizers require more guidance on what data source to analyze, as they lack the necessary infrastructures and freedom to drill down and mine insight at will. Executives must champion data visualizations and build intelligent processes and infrastructures around BI tools. 69% of interactive visualizers have an executive-level champion of analytical initiatives. C-level promoters of BI tools secure investments in new technology and ensure that the end users are properly supported. Adopters of interactive visualizations are also significantly more likely to have established data governance policies and in-house analytical training. Improving visualizations part 2. Interactive visualizers work With live data moving as swiftly as possible, interactive visualizers are over twice as likely as static visualizers to have real-time analytics. Users have the opportunity to work with streaming data and examining multiple angles on business events as they happen. Interactive visualizers are also more likely to adopt data management and quality tools as well as in-memory analytics. These are the references. A bar chart breakdown, part 1, based on the value construction dataset that I have submitted. A bar chart encodes the value in the length of a bar across an axis, so for that we're going to use our construction. Here we have an x-axis and the length of the bar denotes the amount of sales in our dataset. Here are other examples of bar charts and their breakdown. A line chart breakdown. A line chart are used to compare changes over time. The line chart is the best choice. This works by plotting the date on the x-axis and one or more measures that you're interested in on the y-axis. The value of the data is only for seasonal purpose. The data portrays a loss in revenue during the summer months. Construction should be limited. Here is the pie chart breakdown. The pie chart is probably the most commonly used, but is also one of the most abused visualization types. When used correctly, it can be effective, but far too often it gets misused and used the wrong way. Only use it with limited information. Here's the tree map chart. One of the reasons why visualization data is so effective is that it enables us to look at large volumes of data that would have been impossible to analyze in traditional spreadsheets. Use tree map when abundant amount of data is needed to be visualized. Here is an area chart. An area chart or area graph displays graphic and quantitative data. It is based on the line chart. The area between the axis and line are commonly emphasized with colors, textures, and hatchings. Commonly one compares with the area chart 2 or more quantities. Here is the column chart. It is a graphic representation of data. Column charts displays vertical bars going across the chart horizontally, with the value axis being displayed on the left side of the chart. This concludes our lesson.